In this video, we're going to be looking at negative exponents. So what we've had in the past few days is you've had negative exponents in your answers, but we've just left them like that. So what we're going to look at today is what you're going to do to properly write your answer, because you don't want to have a negative exponent in your answer. So, for instance, with a negative exponent, you're going to have something like 2 to the negative third power. So what you want to do is anything with a negative exponent will get moved to the other side of the fraction. And I'll show you exactly what that means in just a minute. But then whenever you move it, then the exponent becomes positive. Okay, so for instance, if we have m to the negative 2 power over n to the negative 4. Okay? Anything with a negative exponent gets moved to the other side of the fraction. So this m to the negative 2 needs to get moved down to the bottom. And then this n to the negative 4th needs to get moved up to the top. So then we're looking at n to the 4th over m to the 2nd, or m squared. And then that would be your final answer. We can't simplify that any further. And then that's it. So we're going to start off doing a couple of really easy examples, and then we'll get into the more lengthy and more difficult ones. So the next one, we're going to have 4 to the negative 2, x to the negative 4. Now this one is not written as a fraction, but remember, we can always put this over 1. So then when we go to move, we need to move the 4 to the negative 2 down to the bottom, and the x to the negative 4 down to the bottom. So we have 4 squared, x to the 4th. But now, I don't have anything left on the top. There's nothing left up here. So you're going to fill that in with a 1. So you'll have 1 over 4 squared x to the 4th. Now we can simplify this further. The 4 squared is 16, so we'll have 1 over 16 x to the 4th. And then that would be your final answer. All right, number 3. What if we have a fraction? So let's say we have 1/8 to the negative third power. Okay, so what you're going to end up doing is you are going to flip the entire fraction. So that's going to become 8 over 1, which again is just 8. So I'm just going to use 8. And then your exponent becomes a positive 3. And then 8 to the third power, 8 times 8 times 8 is 512. All right, example 4, we're going to start getting a little more lengthy here. Let's say we have a to the negative 2, b cubed, and c to the negative 4 over x to the 7th, y to the negative 3, z to the negative 8. Okay. So let's see here. Things that need to be moved. The a squared needs to get moved. I'm sorry, a to the negative 2, I guess. The c to the negative 4 needs to get moved. Those both need to get moved down to the bottom. And then on the bottom, you're going to have 2 that get moved. The y to the negative 3rd and the z to the negative 8 both of those are going to get moved up to the top. Okay, so it looks kind of like a lot of jumbled up mess here. So let's take this one thing at a time. On the top, I had the b cubed that did not move. But then I had this part that needs to get moved. So I have y cubed and z to the 8th. Okay, so the top is done. On the bottom, I moved the a squared down and the c to the 4th down. And then I still had the x to the 7th that did not get moved. Now notice everything in here is in alphabetical order. The top is in alphabetical order, the bottom is in alphabetical order. So try to keep yours like that also. And then that's it for that one. We can't simplify that anymore. All right, example 5. If we just have 2 to the negative 4th power, this is how your IXLs are going to start out, just like this one. Technically, this is 2 to the negative 4th over 1. So remember, we have to move that down to the bottom. So we have 2 to the 4th on the bottom. Nothing was left on top, so I'm going to put my 1 there. And then answer this. 1 over, well, 2 to the 4th is going to be 2 times 2 times 2 times 2, which is going to be 16. So this is going to be 1 over 16. All right, and then we're going to look at one more example here. So example number 6. And this one's going to have a couple more steps involved with it. So we have a to the 5th, b to the negative 3rd, c to the 10th, over a to the negative 4th, b to the negative 3rd, c to the 5th, I'm sorry. Now notice we have a's and b's on the top and the bottom. Okay? It's a division problem. And we learned earlier this week that in a division problem you subtract your exponents. Now, you could subtract them like they are, but I know a lot of you would just rather deal with all positive exponents. It makes it a whole lot easier to subtract. So let's go ahead and move everything that we need to move first. So I need to move the b to the negative 3 down to the bottom. And then on the bottom, I need to move the a to the negative 4th and the b to the negative 3rd. Both of those need to get moved up to the top. So let's see what we have here. On the top, what's left, I have the a to the 5th and the c to the 10th that were left over. And then I moved up an a to the 4th and a b cubed. So that's everything for the top. On the bottom, I was left with this c to the 5th, and then I moved down a b cubed, and then that was it for the bottom. Now, we need to simplify this up a little bit. On the top, remember, this is nothing but a string of multiplication. And in a multiplication problem, you have to add your exponents. So I have a to the 5th and I have a to the 4th. Together, those will make a to the 9th. And then I still have b cubed and c to the 10th. On the bottom, nothing I can do. I am going to put them in alphabetical order, though, b cubed and c to the 5th. And then finally, in a division problem, you subtract your exponents. So I have a to the 9th on top. That's just going to stay a to the 9th. With your b's, you have b cubed and b cubed. Well, 3 minus 3 is 0. So that would give you b to the 0. But remember, anything to the 0 power is 1. So those basically just cancel each other out. And then your c's, 10 minus 5 is 5. So a to the 9th, c to the 5th, and that's all you can do with that one. So this was negative exponents that we looked at in this one.